All right, let's crack the code on geometric progressions. In the next few minutes, we're going to build your complete toolkit for mastering these, using real examples from past ICSE exams. We'll break down everything, from the basic formulas to the tricks that solve those really tough problems.
Okay, so let's dive right in. Before we build anything, we gotta lay the foundation. You're probably pretty comfortable with arithmetic progressions, APs, right? That's where you're just adding or subtracting the same number over and over. Well, think of a geometric progression, or GP, as its cousin, but instead of adding, we're multiplying. That's the big switch. We've moved from adding to multiplying.
And that number we keep multiplying by, it's got a special name, the common ratio, which we usually just call R. Honestly, this is the single most important piece of the entire GP puzzle. It's like the DNA of the sequence. To find it, all you do is take any term and divide it by the one that came right before it. This little number is the key that unlocks pretty much everything else.
So, now that we get the idea behind it all, let's get to the how. It's time to open up our toolkit and grab the two most powerful formulas you're going to use for pretty much any GP problem that comes your way.
Here it is, your first essential tool, the nth term formula. Now imagine you need to find, say, the 50th term in a sequence. Are you going to sit there and multiply it out 49 times? No way. This formula is your shortcut. It lets you find the value of any specific term in a flash. Here, A is your first term, R is that all-important common ratio, and N is just the number of the term you're hunting for. Let's see this formula do the heavy lifting for us. For a sequence like 2, 4, 8, 16, our first term, A, is 2. The common ratio R is just 4 divided by 2, which is 2. So to find the 10th term, we just plug it all in. T10 equals 2 times 2 to the power of, and be careful here, 10 minus 1, so 2 to the power of 9. That gives us 1,024. See, no need to write out 10 terms. The formula did it all.
Okay, but what if you need to add up the first 10 terms, or the first 100? That's where your second major tool comes into play, the sum of n terms formula. This is your go-to for finding the total of a whole chunk of the sequence, without adding them one by one by one. Now, you might see a slightly different version of this formula floating around, but don't worry, they both give you the exact same answer. It's just written a bit differently to help you avoid getting negative numbers. It's a massive time saver.
So, how does this formula hold up in a real exam situation? Let's put it to the test with a problem from an actual ICSE paper. Now, this one's a little tricky because it flips the question around. We're given the final sum and we have to work backward to find n, the number of terms it took to get there.
And this is how you break it down. First, you just identify your variables. A is 9, our common ratio R is 2, and the sum Sn is 2295. Step 2, we plug those values right into our sum formula. After a little bit of simple algebra, we find that 2 to the power of n is 256. And since we know 2 to the power of 8 is 256, then n has to be 8. Simple as that. It took exactly 8 terms to reach that sum.
Now for the fun part, the advanced gadgets. You've got the core tools, but these special properties, well, they can help you solve some really tricky problems, and more importantly, save you precious time during an exam. Think of these as your secret weapons. These properties are just fantastic shortcuts. For example, did you know that if you multiply every single term in a GP by the same number, the new sequence is also a GP? It's true, and the same thing happens if you take the reciprocal of every term, or if you raise every term to the same power. Keep these in your back pocket because they can help you see a solution way faster. And here's a really special one, the geometric mean. It sounds complicated, but it's not. If you have any 3 consecutive terms in a GP, let's call them A, B, and C, that middle term, B, has a really cool relationship with the other two. B squared will always equal A times C. This is a super important concept for problems that involve any 3 terms that are equally spaced out. So you might be asking, when am I ever going to use that? Well, here's a perfect example from a real exam. This question looks tough, right? But it's just a direct test of the geometric mean. Look at the term numbers, 5, 8, and 11. See how the 8th term is smack in the middle of the 5th and 11th? That means P, Q, and S act just like 3 consecutive terms. So the rule has to apply. Q squared equals P times S. It's a classic test of that principle.
All right, workshop time. We've defined what a GP is, we've got our main formulas, and we have our special properties. We have officially built the complete toolkit. So now, let's put it all together and walk through a full problem from start to finish.
So, how do we attack this? The first step, every single time, is to decode the problem. you got to play detective. What information are we given, and what exactly are we trying to find? We have A, the first term. We have T6, the value of the sixth term. The big missing piece of our puzzle is the common ratio, R. Once we find R, we can build a whole sequence, no problem.
So here's our game plan. We've decoded the problem. Now, which tool do we pull from the kit? Well, since we're dealing with a specific term, the nth term formula is the perfect choice. We just substitute the values we know. 1024 equals 1 times r to the power of 6 minus 1, which just simplifies to 1024 equals r to the power of 5. A quick check tells us that 4 to the power of 5 is 1024. So our common ratio, r, is 4. And just like that, the puzzle is solved. And now for the easy part, the final step. We just build the sequence. We start with our first term, 1. We multiply by our common ratio, 4, to get the second term, which is 4. Multiply by 4 again, you get 16, then 64, then 256. And there it is, our final answer. The first 5 terms, all found logically using the tools from our kit. And here's one last piece of advice that ties this all together. A tip straight from a teacher. See, knowing these formulas is one thing, but being able to use them quickly and accurately when the clock is ticking in an exam, that's a whole other skill. The absolute best way to prepare is to practice with a timer. That's how you get ready for the real thing. So let's do a super quick recap of the toolkit we just built. First, a GP is all about that common ratio. It's all multiplication. Second, your two main tools are the nth term and the sum formulas. Master those. Third, use those special properties and the geometric mean as your expert shortcuts. And finally, always follow the process. Decode the problem, select the right tool, and then solve. And that's it. That's your complete toolkit for geometric progressions. We've armed you with the core concepts and the strategies to solve real exam problems. So the only thing left to do now is to go use it. Go on, open up that textbook and see which of those problems looks a little less scary now.